Dear students, now let us explore about Nash equilibrium and let us try to understand Nash equilibrium. So, dominant strategy equilibria are very nice when they happen. Actually, it doesn't happen uh, all the time. So, this is the problem. In last video I said about the equilibrium will happen when there will be dominant strategy in game theory, but this dominant strategy may not happen always. For example, let us see let us observe the table which is given in this video. From table we can mark that when B chooses left, the payoff to A is either 2 or 0. Please look at the table. When B chooses left, the payoffs to A are 2 or 0. When B chooses right, the payoff to A are 0 or 1. So this means that when B chooses left, A will choose top, and when B chooses right, A will choose bottom. Therefore, A's optimal choice depends upon what he thinks B will do. Means A's choice. So the Nash equilibrium, what is Nash equilibrium? The Nash equilibrium means, in this example, if A's choice is optimal given B choice. Similarly, B choice is optimal given A's choice. Means, in other words, we can say that Nash equilibrium means each player is making the optimal choice given the other player's choice. So in this case we can say that there is Nash equilibrium. Let us look at the table. Think about strategy top and left, or we can say that the strategy for player A is top and for player B is left. So top left strategy, if you think, the corresponding payoffs are 2, 1. Means A chooses top. If A chooses top here, in case of top left strategy, if A chooses 2 or if A chooses top, then best thing for B is to do for choice of left. Why? Because payoff to B from choosing left is 1. Then choosing right is 0. Since here one payoff for player B is greater than 0, he has to choose left. This choosing left for player B depends upon the player strategy top. Similarly, if B chooses left for player A, again I am saying, similarly, if B chooses left, then the best thing for A is to choose top. Means if A knows that B is playing for left or choosing left, then for player A, top strategy will be better than bottom, because the top strategy has payoff 2 which is greater than 0 for bottom strategy. So if A knows that player B plays left, then A has to choose top strategy, not bottom strategy, because top strategy has more payoff, that is 2, than bottom payoff 0. So clearly it is saying that if A choice is known, B will choose his strategy. Similarly, if B's choice is known, A will choose his strategy. So in one sentence we can say that the Nash equilibrium is is uh, is the player, sorry, here the Nash equilibrium is that player is making the optimal choice given the other player's choice. So in this case, top left, that is 2-1, top left strategy consisting or consist of payoffs 2-1 has a Nash equilibrium. Again I am saying here the strategy top left consisting payoffs 2-1 has a Nash equilibrium. Why Nash equilibrium? Again I am saying because suppose let us say A knows that B is playing left. So if B will play left, for A accordingly he has to choose either top or bottom. So for player known choice left, for player A top will be better, that is 2. Payoff is 2 which is greater than 0. Bottom's payoff 0. Similarly, if player A plays top, then player B choice will be left, because in this case payoff is 1 which is greater than 0 in case of right. So the Nash equilibrium, again I am saying that each player is making the optimal choice given the other person's choice. Right. Here one thing I would like to say that Nash equilibrium is a generalization of Carnot equilibrium. Okay. Here choices are, let us say, output levels. If we consider the choices about output levels, then each firm choose its output level taking the other firm's choice as being fixed. Okay. So assume that, let us say, firm continued to produce the output level it had chosen. That is, it continued to play the strategy it had chosen. A Carnot equilibrium occurs when each firm is maximizing profit given the other firm's behavior. So this is precisely is the definition of Nash equilibrium. So in our example, please look at the table. Top left strategy consisting payoff 2-1 is a Nash equilibrium. Okay. So here this is all about Nash equilibrium. Here two problems with Nash equilibrium. There are two problems with Nash equilibrium. One is Nash equilibrium may happen more than one. How? How is it so? So if you see the table, there are more than one Nash equilibrium existing, and this is the problem. In a game, we may not restrict that Nash equilibrium will happen with one payoff or one strategy. Means one like top left. Here we saw that the top left strategy has a Nash equilibrium, but this Nash equilibrium is not only the Nash equilibrium. There may be the chance of other Nash equilibrium in this payoff matrix. For example, look at the table. If player B plays bottom, then if player A plays bottom, player B will choose whether he has to play left or right. So here, since player B knows that player A is playing bottom, for player B, the best strategy is to play right, because in right he has payoffs 2 which is more than 0 in left. Similarly, if player B plays right, this This is known to player A. If player B plays right, then player A has to choose bottom, because in this case payoff is 1, which is more than 0 of top strategy. So the bottom right consisting of the payoffs 1, 2 is also another Nash equilibrium. So here are two Nash equilibrium occur. Here two Nash equilibrium occur. This is the first problem. Second problem is that in this kind of game, there may be the chance of no Nash equilibrium. Some games are there where there may not be the chance of Nash equilibrium. So these two are the shortcomings of this type of game or in Nash equilibrium. This is all about Nash equilibrium. Thank you.